Right, let's go ahead and get started. We've got quite a few attendees, a good topic for everyone today. Today's Cloud Native Computing Foundation webinar is monitoring microservice applications. It's about visibility, and it isn't. I'm Lee Calcote. I'm head of technology strategy at SolarWinds and the CNCF ambassador. I'd like to thank everyone who is joining us today. We'd like to send out a warm welcome to Chris Farrell from Instana. Chris will be our presenter today. Interesting fact, Chris joined Instana around about a year ago. I think he started his first day at DockerCon. So what an appropriate first day for him. We certainly appreciate Instana sharing their experience on monitoring microservices with all of our listeners today. A few housekeeping items we will cover just before Chris comes on. Note that during the webinar, you will not be able to speak as an attendee. However, questions are highly encouraged, so there is a chat window or a Q&A function. Feel free to drop your questions in there, and we will answer them as we can throughout Chris's presentation and bubble those up to Chris at the end of our call. Yes, preemptively, to answer the question, this session is being recorded. Not only will the link to the recording be sent out, but so will Chris's presentation. And with that, let me hand it over to Chris Farrell. Chris?
Thank you, Lee. And thanks to CNCF for inviting us here today. I'm quite excited to be talking about managing microservices, and specifically this topic was amusing for me to put together, that managing microservices is about visibility, and it's not. We'll take you through the agenda real quick. We're going to start with a bad joke. That wasn't it. I guarantee you the one I'm going to tell is going to be worse. We'll talk a little bit about the evolution and revolution of application performance management as it pertains to really the evolution and revolution of how applications are built and delivered. We're going to talk about specifically how containers and microservices have created a new brand of application that we refer to as dynamic applications. And then we're going to talk about how the visibility angle is one important aspect of monitoring these great new things, and then how artificial intelligence and really specific automation and artificial intelligence are required to kind of take that visibility and make it useful from a management perspective, from an operational perspective. Finish up with a little bit of an AI APM practical implementation, describe some specific ways that helps. And then at the end, we'll have some times for your live questions and hopefully some good answers. Along the way, I might show you some screenshots or might even show you some live product if it makes sense to kind of tie in, but I really wanted to keep this at a level of talking about concepts and solutions as opposed to show you product. But you will see a couple of glimpses of the Instana product along the way. So a little bit of physics humor here to get some people up to speed. Schrodinger's cat is a famous physics experiment about observability. And essentially, Schrodinger did an experiment where he put a cat in a box and put something lethal in the box with the cat, but it was on a time thing, or maybe it was something that was fragile and might break. And the question is the cat dead or alive? And of course, you can't really know without opening the box and ruining the experiment. So Schrodinger came up with the answer that the cat is both dead and alive while it's in the box and you're not seeing it. Many of you probably already know that, but one of my favorite jokes around this is that Schrodinger's cat walks into a bar and it doesn't. And the reason I love this joke, I hope some of you are laughing, some of you are probably groaning, but the reason I love it is that because managing microservices and specifically microservice applications is about having the right level of visibility into all the things that are part of those applications. And at the same time, it's not. So very much like Schrodinger's cat, it is both a critical thing and at the same time, it's not critical to really understand what's going on in the microservices world. To understand why we've gotten to that point and why that's important, I wanted to talk a little bit about application performance management specifically and what that has meant over the years to organizations of many sizes. So let's talk about the first generation of APM. I actually was part of the first generation of APM, and yes, what that means is that I'm really, really old. Uh, when the first APM solutions came out around 18 to 20 years ago, the critical business applications at some of the world's largest companies were just then moving to a three-tiered monolithic Java application structure. And I literally just mean Java. There were no other languages to write these things in. They were done in Java. There was actually a lack of confidence in pretty much everything about this architecture. The app servers were flaky. The technology itself was kind of new and flaky. You weren't really sure what you were going to get from your programmers. And of course, what you were doing was migrating a set of legacy applications written on mainframes, written in COBOL, written in running on AS400s and in these client server environments, and trying to put them into this integrated middleware type of application. And there were all kinds of funky things that might happen. The biggest need of this world was production code visibility. Programmers had tools that could show them the internals of their code and their applications, but not in a scaled production environment. And so what they were able to test and what they were able to see in production just didn't match. So that's why the first generation of APM tools was all about providing visibility of code in production. And there was a little bit of understanding of what transactions were going on there. And then the idea was to try to get an understanding of business logic too. And so each of the tools that came out during this 4 to 5 year period had some different ways of manually handling what transactions looked like and what business logic looked like. Now, this was the visibility that was required by the tool users to monitor things, to detect problems, to see where the problems might be, and to get to the real heart of why you have an APM solution, which is to solve production problems. So that's first generation, and then things shifted a little bit. More languages came around. It started with .NET becoming a more prevalent used language, well, not a language, C#, but a used platform for developing and deploying these applications. More importantly, reuse started becoming a buzzword. And as the app servers themselves became stronger and more robust, and as more experienced programmers came along, and as the companies became more comfortable with these integrated middleware type of languages and applications, the service-oriented architecture evolved. And so you started having distributed applications. And it's funny to talk about them being distributed because they were, but we're about to talk about something that's even more distributed than the nose. So, but code mapping became a part of this, and how you gathered things together and grouped them together. And so a new generation of tools evolved that were able to understand the nuances of distribution, of loosely connected components, and to provide that architectural information in addition to the code level visibility that you needed. But all this was still done at a code visibility level, just required a different way of getting the data and really a different way of correlating data. The biggest difference between Gen 1 and Gen 2 was the ability to map these internal application systems out and have a view of this fully distributed world. Well, let's fast forward a little bit, about another 10 years, and we start to see the evolution of the application space itself into containers. And in fact, I was just talking with someone a few weeks ago about how quickly containers were not only adopted by early adopters, but how quickly these same companies that were so reluctant 20 years ago to even have one Java application are really testing, playing with, and deploying containerized applications. They have been just so quick to be adopted and used in critical business applications for many different reasons. One is they're easier to deploy all the different technology platforms that people might deploy. They enable a faster velocity on application delivery because they enable every single developer to run their favorite and best specific platforms that they need for their services that they're responsible for. So containers really help us enable this fully distributed development team where every developer is operating on their own as well as part of the broader team. So they are the basis of many microservice applications. And as I said, it's been an extremely fast adoption cycle as far as how large companies and small companies are deploying production level containerized applications. So with most switches and platforms, the monitoring tools have to switch as well. And I will tell you that monitoring microservice applications requires a whole new set of visibility. Why? There's a couple of reasons. One is we're not dealing with one language. We're not dealing with two languages. We're dealing with a dozen languages or more. So you have some applications that are completely written in things like Scala or Node.js, or we have graphic pieces, UI pieces written in Ruby. We have things that are written in Python. We have business logic being put in Python. We have PHP making a comeback, and we have customers that are running full-blown transactional PHP applications. The reason for this is that every problem that the developers are trying to solve, every function they're trying to build now has some very specific needs, and they are no longer tied to, well, our standard is Java, so I got to go figure out how to do this in Java. They're going to use the language that's easiest, most robust, maybe the fastest to code and get out there. The second interesting thing is that business logic and transaction handling are now built into some of these non-code components. So whether it's one of the new middleware technologies, messaging technologies, or a NoSQL database, there's not necessarily, everything isn't necessarily tied to that piece of code anymore to make decisions, to complete transactions, or even to forward a transaction system request onto another component or onto another backend system. And finally, monitoring all of the different microservice platforms that developers use and the technologies that they choose to develop and deploy, every one of them now has a different requirement. As an example, when I was part of that APM Gen 1, again, we were all excited because we had this production Java visibility, and then you built connectors onto that essentially to watch specific backend systems, but there were maybe 3 or 4 of those. Today, we're dealing with over 100 different microservice platforms, and I've mentioned what some of them, the way that some of them fall into the architecture world of messaging systems and storage systems. We have cache-specific things. We have databases specific to search, like Cassandra and Elasticsearch. So there's all kinds of specialization that developers can use to make it easier to develop, easier to architect, and easier to deploy their microservice applications. So what does that mean from a visibility perspective? So here's the first half of our premise. Monitoring microservices is about visibility. The first is the same as any other APM solution, code level visibility. But it's code level visibility for all the different languages, the polyglot of languages that are out there. And rather than having that visibility to help build an application picture, instead it's there for when you need it. When the problem ends up showing that it's inside a Python component, then it's good to have the Python code level visibility so you can drill in and figure out what's going on. But it's not necessarily needed to figure out how your applications are built and how they're being used to actually do business logic. Secondly is understanding the technology platforms that are being used. And specifically, there's performance data going on both inside the platform and in its response to application requests. There's transaction information to understand what's going on. There's the configuration itself of what's in that system, and if it's a layered system. So, for example, if it's a Cassandra system running in a Docker container in a Kubernetes orchestrated environment, or even better, a Kubernetes engine from OpenShift or IBM or Google, now you have these layers of different configuration and performance pieces that you want to be able to see so that you truly understand what's impacting application performance. There are two more pieces. The next one is dependency mapping between all the different pieces. Now remember, we said at Gen 2 APM, SOA created this distributed application environment where it was important to map individual application components, but they were application components. They were the pieces of Java that dealt with each other and that they would be reused. What we're talking about here is dependency mapping between all the different microservices and technologies that you use and how they band together to create the broader applications. And that dependency, of course, changes over time. We're going to talk about that in a minute. The last piece of visibility that you want is the ability to trace all the requests that come through end to end across the entire distributed application. And of course, there are many different ways to trace these days. There's OpenTracing, there's Jaeger, but also you have tracing built into the tool, some of the tools themselves. For example, at Instana, we auto trace 100% of requests ourselves while also supporting the third-party tracing systems, because there are sometimes there's things that you want the developer or the developer feels like should be exposed other than service level KPIs or performance information. So, but it's not, now we're going to start talking about, it's not just about visibility. With all that comprehensive performance, configuration, and trace data, what else would you possibly need? And the reason that you need more is because of a dirty little word in microservices, or maybe an exciting little word, depending on where you sit. And that word is dynamism or dynamic. It's the dynamic aspect of these applications that make just pure visibility, A, difficult to achieve, but also difficult to use and be the only thing that you need. Why? Because you're spinning up and destroying containers and microservices all the time. Now, sometimes you have an application that it's not destroying these things all the time, but the idea is that these technologies are built to allow you to be dynamic in how you deploy and how you utilize your resources that you have available to you. So the truth is that over the last few years, what we've seen at customers is the average lifespan of a container has shrunk by about 80%. And I expect that to continue to shrink as we get into more agile, faster velocity development teams. There's also the idea of those agile, faster velocity development is you're trying to get to that continuous integration, continuous delivery aspect. I was just talking to a customer last week where they used to have 2 updates a month, and now they have about 200 updates a day, with 20 of those updates essentially being production updates on an average basis, 20 production updates a day. In that environment, just having visibility isn't enough. You have to be able to deal with this dynamic aspect. And then the last piece of the dynamism is all those fluid relationships and dependencies that is the reason we're going to these environments. No two transactions necessarily follow the same path. So the ability to understand exactly where things go is very important as you get to that problem-solving aspect of what's causing issues in my microservice application. So dealing with this requires visibility because you have to have all that information, but it's just raw data if you can't do anything with it. So what we found is that it requires really programmatic AI and automation to effectively monitor not just the fact that these things are running, but also the overall performance. So let's talk about what these things are doing. If we think about the really, really old days, even before the 20-year rewind I talked about earlier, we had mainframes and every application was essentially contained on one place. So you only had to monitor the one thing. And then client server came along and a set of tools came along to monitor it. Then we got to the monolithic 3-tier applications. We got to SOA a few years later. Then we started talking about microservices. Then we started having containerized microservices. And where are we going? We're going to orchestrated containerized microservices. Now, all of these things are creating a kind of enabling development to move their velocity, to quicken how they deploy, to get closer to continuous integration, continuous delivery. Now, the interesting thing, and what I always talk about is every tool that makes it easier and faster for developers to deploy makes it more complex and more difficult for IT operations or DevOps to actually monitor, configure, and manage the performance of these applications that are running. And because of the way that these are going, automation ends up being a key part of being able to actually handle all this. And before we talk about what we're going to automate, I like to tell you this comes right from our CTO and his talks about AI and why AI is important. And so there's this uncertainty determination quadrant, and this is actually from a financial planning system. So it's actually kind of neat to apply these aspects of complex system management from non-IT into our IT environment. So there's this matrix of what's known, what can we know, what's unknown, and what do we not know about that. So there are things that we are aware of and we understand it. There are things that we are aware of, but we don't understand what we're seeing. There are things we understand, but we don't really know that they're happening. And then there's, of course, there's the evil of things we don't know are going on, and we actually can't understand them anyway. And the reason this quadrant is set up this way is this is what you have to think about from a DevOps perspective when you consider these complex dynamic systems that are being deployed. And we talked about the polyglot of technologies. I describe this new world as kind of the wild, wild west of technology. You essentially, in the past, when you're 3-tiered, you'd sit down as a group with some senior architects and you decide, well, this is our web server technology we're going to use. This is our app server technology we're going to use, and this is our database technology that we're going to use. And maybe you had a transaction system or some messaging that you did, but you picked the technology that was going to be standard and everybody would use. Well, in the microservices world, that goes out the door. You're like, hey, our database that we use is SQL Server, and 3 developers say, well, the best database I can use for what I'm doing is MySQL. So that's what I've programmed in. And oh, by the way, it was so easy to deploy a container that it's actually running. And so DevOps has to be able to pick up and monitor and manage these things that they didn't necessarily pick as part of it. And of course, the more complex the system, the broader the set of tools that you use. So when you think about the classic APM tools, whether Gen 1 or Gen 2, and what they're doing to troubleshoot, and you apply it to the quadrant, they understand the known unknowns, right? Hey, I know there's a problem, but I'm not really sure what's going on with the business logic or with the requests. And they can, of course, they can solve the already known knowns, all by focusing in on the application. But they can't really get beyond those things because they can only monitor the things you told them to monitor and the things that you knew about ahead of time. And so that's why you're trying to get to the next set of things, and that requires AI. Now, interestingly enough, AI has been a big buzzword, of course, not just in IT and monitoring, but across many of the other systems we use. I probably get a dozen emails a day from marketing technology vendors telling me how AI is going to help me find people that are ready to buy, or find better leads within my own database, or be able to set messages at a show that are going to attract more of the audience I want, all by applying AI. And we're not talking about Cyberdyne systems here. We're talking about a couple of different axes of different types of functionality that we all recognize as part of the AI base. But what we want to talk about, what we like to talk about, is how each and every one of these pieces go together to create a more complete system to help you deal with these complex environments. So the first thing that you have as part of any AI is a knowledge base approach. And of course, there's different ways you can have a knowledge base. You can have a knowledge base where your community is contributing to each other and you're indexing that. And that's a good start. You might even curate that so that you can lift up answers that are better and try to anticipate questions. This is where you start to get a little bit of intelligence added in there. But in reality, as things change, the rules and the situations that you have this knowledge base for, they start to shift. And all of a sudden, the questions about an app server don't apply the same way they do anymore, because your app server isn't being used in the same way anymore. And so you can set these predefined rules, but in reality, they're always shifting and changing. So it's a good first step, the knowledge base or rule-based monitoring. But again, going back to our quadrant, you have to know what you're dealing with ahead of time in order to have that knowledge base be able to help you. The next thing that people talk about is doing deep statistical analysis, another branch of the AI axis, so to speak. And whether you call it advanced statistics or deep statistical analysis, you're essentially doing a lot of correlation and applying statistics. But when you apply statistics, you actually are kind of at the whim of the data. And if some of you have had to make reports, maybe you've noticed this. And I do this in my day-to-day job myself. I get asked, what's the average life cycle of a lead to go from one step to the other? And while that's an interesting statement and an interesting piece of data, maybe the median is more interesting because that's directly in the middle, because you could get skewed data. And what I love about these pictures on the right is that they actually all show the same averages for X and Y. But obviously they're a whole different, each one is a different data set, but it shows you how data can be skewed. And if you ever get some time, go out and look for the dinosaur statistical distribution, and it's actually fun. I could create all kinds of distributions, including fun pictures of dinosaurs that all end up with the same mean and the same standard deviation. So while applying statistics is useful and another thing that can help, you have to model it correctly, or else you're going to end up simply accepting the fact that every data set is exactly the same. But again, a good part of a broader, more complete AI organization. Now let's talk a little bit about why structuring your statistics versus having a broader understanding is important. This is actually a screenshot from the product. And one of the interesting things here, and I know I'm about to say something you're going to go, no, you're crazy, Chris. This is actually a very simplified view of the application that this particular instance is monitoring. Why is it set up like this? It's set up like this because we as a IT group, we're accustomed to looking at a tier-based map of our applications. We create tier-based architectures. We think of them in steps of this server to that server and so on, back to storage. So we create this view to kind of help people understand a little bit about how things are built and what's going on. This is a structured view of the world. But if I were to start to dive into what the services actually look like that make this view, you start to get a little bit less structured. And now you start to see that it's more like just a random collection of services that tie together. But believe it or not, this is actually still structured a little bit. We wanted to create a view that allows you to understand a little bit more of the complexity of what's going on in your application without essentially giving you overload of the brain. What does this really look like? This is a simple application in a pure microservices mode, because every microservice has the ability to come up, get destroyed, uh, communicate with any other microservice when and where it wants, and have very loosely connected connections. So you end up with essentially this blob of things that tie together. So one of the things that you have to do as a monitoring tool in this world is to help not only find all this data, remember that's the visibility part, but also be able to structure it in such a way that it's understandable, at least from a organizational perspective, to the ops team. No individual is going to be able to understand everything about every application anymore. That's just not going to be possible. But also, just because I have this view and this is the way the data looks, you don't want to just throw this at people. So hence coming back to this structured view of the world. So now that we have this ability to kind of structure everything together, we can start applying the next layer of AI to this. And that next layer is one that really most organizations that start talking about having AI as part of their tool, whether it's a marketing tool or an IT tool, that's where machine learning starts to come into place, right? Machine learning starts with some deep statistical analysis, but it has to go on. It has to start taking an understanding of, well, okay, so this is my standard deviation, this is my mean, but what are some of the other things we're looking at? What model do we want to apply? Can the machine actually learn what the model, what the distribution looks like, and start applying different statistical models to it? So now you start to get into some knowledge base concepts, not just knowledge base about technologies, not just knowledge base about error codes or things like that, but now starting to apply statistical information, knowledge about how things are modeled, how data is distributed, and depending on that model and distribution, what should you do with it? How are you going to determine whether things are good or bad? Now, why is that important? Because in an application that looks like this, and again, this is actually a simple application. This is our demo application. There are applications that in real life are 10 times, 100 times, 1,000 times more complex than this. So how can you apply that in a way to help the end user, that's operations and DevOps, understand what they need to do next? Because in this world, you can't configure monitoring. You can't go set thresholds. You can't go say, this is a piece of metric that I want to look at for this type of technology. That is a non-starter. You will spend all the time you have and then still not be done with setting up and configuring your monitoring. So you have to start applying these layered aspects of automation and AI. So machine learning concepts, but on the statistical analysis of things. And then, so that the nice thing is that once you start training your system on algorithms and distributions and statistics, all of a sudden, now those unknown unknowns and those start to move to unknown knowns. And so you start to move around that quadrant, which means that you, the people, can now take better actions or even start to understand what things are going on that need your intervention to do stuff. So now that we've talked about some of the basic premises of AI and APM specific types of situations, now let's talk about what it means to practically implement this in an APM environment. Well, you start with this combination of the knowledge base, but it's a multi-tiered knowledge base. It is technology based. It does have information that it knows about what you should do with a Cassandra database or an Elasticsearch, or what you should do with Redis database or with Kafka message queue. And then you add in the aspect of the statistical understanding, knowledge base of those things. And then you start to apply the correlation and start to actually put the machine learning in place. So the idea is we want it to behave similar to humans in the classic APM space. A problem has occurred. How do I see where the problem is, and where do I start debugging to figure out where things are going? So, and of course, the nice thing about having a computer do it is the computer doesn't get tired. The computer at 2 in the morning doesn't get up with a phone call to the bedroom and then have to go, well, I'd like to shower and shave, but I need to be getting into the office to do this now. Or hopefully you can log in from home to do it. But either way, you're groggy, you're tired. The computer, the system, the AI does not get tired, does not have any of these things get in the way. And then we haven't really talked about it specifically here, but when you talk about automation, this is where you get to the idea of understanding what the applications themselves are doing, and how you can and how the monitoring gets configured, but also where you should go focus your energies. The idea is to essentially make it so that your operators can focus their attention on the specific problems that are going to impact service and not worry about the thousands of change events and warnings that come up during the day, or even issues that come up with an instance of a container of something, or even if it's in an app server and it's a something that's going to deplete resources. If it's not impacting the end user service, then you don't necessarily have to worry about it. So what can you automate with AI in the APM environment? All these things on the right, and I could read them, but my favorites are issue recognition and correlation of events to issues to service incidents. And specifically, the idea of understanding anomalies from the perspective of they are A, an impact on end users, and B, something unexpected. Anomalies occur all the time, but in the world of computers, and when I say unexpected, I don't mean that the operations team is like, oh, hey, why did the behavior change? We didn't expect that. I mean the system didn't expect that, because the system understands when anomalies are actually part of the process and part of the applications itself. So AI is the essential piece of APM automation that allows you to deal with these dynamic environments. So what we bring to the table, this is the way that we apply this. We actually personify our AI with Stan the robot, and we apply it in this way. We automatically discover what's going on. Otherwise, you're going to end up with too many holes. We continuously align with real-time changes, right? As the life cycle of containers shrink, as more and more things get put into the application, and more importantly, as your development team starts to approach continuous delivery, how do you deal with the fact that all these changes are going? The monitoring tool has to be a real-time adjusting tool to what's going on. You want high fidelity data. Now, here's immediate analysis. You want 1 second granularity. You want 3 seconds to understand a problem. Again, that goes back to the idea of continuous delivery. If you have, again, bringing up the customer I talked about earlier, if you have 20 production updates a day, waiting 5 minutes or 30 minutes to understand that there's a problem with with one of the systems that just got changed. Wow, how many users are going to be impacted? How many transactions are going to fail? How much business are you going to lose? It's critical, especially for the developers part of the DevOps team, to understand, hey, I applied this change, this update, and 5 seconds later, I got told there was a problem. That means I can roll it back immediately, go back to my testing, my drawing board, and see what's going on. The nice thing is, not only do I have that information, I have it historically, so I can go back to my testing system and see why it missed what came out in production. And applying that over time and being able to help you figure out where to start to debug unexpected problems is the kind of my favorite piece. So for any incident that occurs, we kind of drill in and say, hey, here's the issue, or here's the event that you might want to go look at and see. So we actually help you get right to the heart of the problem. Remember, we talked about the wild, wild west. As a DevOps team, as a DevOps team handling a highly complex microservice, it is no longer really tenable for you to have full subject matter experts for every system that's running. So this is a really key piece of how AI helps you by drilling in on any service incident and saying the problem's in the SQL Server database, the problem's in the Kafka system, the problem's in this piece of Java code, and oh, by the way, here's the code level details that you need so that you can get to the heart of the problem. So in reality, in these dynamic applications, AI isn't just a cool thing to have, it's required to get the stuff done. A big part of doing that is what we call our dynamic graph, but in reality, it's modeling. Now, there were some systems, almost all of the tools, the Gen 2 tools, had modeling as part of dealing with SOA. So the industry and the operations team know that modeling is a critical piece of understanding how distributed applications work and how things go. But if you don't have a full model, then you're going to struggle. And especially if you don't have a full model, your program, your AI tool can't make the right decisions, right? So having a model that has the ability to adjust to different architectures, has the ability to apply different statistical analyses based on what it knows in the past, and includes configuration information so that it can understand exactly how everything's supposed to be stuck together and then how it actually is put together. Lastly, I want to talk about a concept, and if you get a chance, and maybe what we'll do is get everyone a copy of this white paper just because you signed up. We have a white paper called The 6 Pillars of AI. Here it's called The 6 Pillars of Application Management, but it's really not about application management. It's really the things that you need to be able to effectively apply AI. And it starts with that: always have the right model of what's going on. So it's auto discovery and real time. It's that 1 second granularity and 3 seconds to know what's going on, because you want to be able to make decisions quickly. The better your data, the better your AI, right? Or another way to think about this is you want to avoid garbage in, garbage out. You have an application model that you can ground both your operations team and the AI in so that everyone can speak a common language. You want to be native to whatever environment you're in. That's the only way and the best way to really have understanding of what the applications are doing. And then the last two pieces are, what do you do with the AI? And of course, we all want to get to the idea of predictive incidents, or predicting incidents are going to happen. And this is one of the reasons that you build a correlated model of events and change events and warnings and how those relate to issues with a specific instance of technology, and how all those issues come together to create service incidents. And that way you can start to do things like predict based on a set of specific change events that you're going to have a service problem with your shop service, or you're going to have a service problem with your payment service, right? And then the last is, now that a problem has occurred, how can we correlate the data and understand what's going on, with every problem, of course, being different, to get down and say, here's the triggering event, or here's the triggering issue that you need to go tackle to figure out and fix what the incident or what the service problem actually is. So at this point, I'm done with my presentation. I'm sure everyone's tired of hearing my voice go on, and we want to open up the floor to questions. So I'm going to stop sharing so that we can go look at the questions, and bring Lee back on, or Caitlin, if they want to talk about things.
Oh, very good. So thank you for the great presentation, Chris. And thank you for leaving time for questions as well. We've got a few questions piling in here. If you do have others, please feel free to put them in now. We'll get those answered. Let's see here. Oh, very good. So, Chris, a question, probably in and around microservices and their monitoring in general, and this has to do with serverless. The question is, how does serverless fit into this world of monitoring?
That's a good and very interesting question. Serverless has both an opportunity to create. Remember, we talked about velocity of development. Serverless is that next thing that's going to make it even faster and easier to deploy things for developers, and even more complicated and more of a headache for operations teams, almost to the point of maybe bringing some of them to tears. And in reality, how you monitor serverless, we talked a little bit, I touched on the different tracing technologies that are available for microservice applications today: OpenTracing, Jaeger, Instana's own auto trace capabilities. The reason that we want to support all the different types of tracing that are out there is, first of all, if you, knowing that there's auto tracing available, if you are having your development team put specific information in to an open tracing instrumentation, then that's data that's important to you. And if it's important to you, it's important to us. So that's one part of it. But one of the other reasons that we know we have to do this is that serverless today really requires you to be able to support the different methods of monitoring built into the platforms itself. So for example, if you were to run Amazon Lambda, you would have to have X-ray support in your monitoring tool to be able to pull that data out. And the nice thing about the way we think about it is that that's a specific component of the system that, of course, has a very limited lifespan, but we also want to be able to include it as we tie into our KPIs, as we tie into the maps, et cetera. So we want to tie our X-ray data in with the data that we get that's not X-ray. So overall, as more serverless technologies come, they will start to include their own monitoring, but also this is where developers instrumenting their apps also help out and can tie together with auto tracing capabilities if you can tie those together, which that's what our approach is.
Got it. Very good. Okay. Let's see. We've got other questions here. One of the questions is, whether or not, if you can trigger actions if any monitoring event occurs, any monitoring event happens.
So this is a really good operational aspect in question, and what tools try to do, especially from a monitoring perspective, we're focused on being able to provide as broad a support as we can, which means that we're going to get all kinds of messages and all kinds of errors and all kinds of different scenarios that come up. And one of the things that you want to have happen, of course, is actions get taken. So when you think about, for example, an orchestration engine, Kubernetes, open source, or an OpenShift version of it, or one of the other Kubernetes engines, one of the reasons you have Kubernetes in place is to start to do things like provisioning new servers when you're running out of resources. And that's great if the environment you're running in matches exactly everything that's going on and you don't start to get resources depleted in ways other than the containers asked for them. And another aspect of that is, how does application performance come in? Like, you might have all these resources to allocate, and you allocate them based on cost analysis and what you have available, but you also want to start thinking about, are we meeting our service levels with this allocation? And so all that ties together to the ability to take actions based on events, based on performance, and based on other things you might see by integrating with the orchestration engine first, and then with other runtime tools that you might have in place. So it's actually one of the more interesting aspects of, probably started with Gen 2 tools, but now with all the modern tools, the idea is, how can I take actions, either myself sometimes, or through the management tools that already exist, like a container orchestration tool or like an AI ops tool that's already out there. So yes, we can do that. That will continue to grow and to become a even faster and more complete set of actions to take.
Okay, got it. All right. We might have one last question here. One of those is, can you show the demo of how to trace the actions from any front-end UI application or an external component down to the microservices call, which are configured in the container?
Well, that's a really specific thing. The short answer is yes. Now I have a demo set sitting here, but let me see if I have any. In our demo system is very specific in the way that it throws incidents out there. So I don't have any incidents to show you that I can actually show you the auto trigger. But let me, in answering this, let me real quick. I'll share the screen just so you guys can kind of understand the way that things might work from that perspective. So when you deal with applications, of course, in a microservices environment, it's important to actually understand how your infrastructure is mapped out. So we have this nice big picture that can be organized by containers or it can be organized by hosts, and each specific place is each specific picture depends on what's running. So these are actually bare metal servers. So each slice that you see in these are actually processes. So over here, here's a Spring Boot process. There's a RabbitMQ process. Now down here, these are all my Docker containers. So every slice here is a container. Remember I talked about running native. So we're actually monitoring each parts of these in the way that makes sense for them. So over here, the agent's running as a host process. Over here, the agent's running as a Docker container. So that it can actually work specifically within the framework that's there. And then, actually we can gather these all up and look at individual containers, or we can actually dig into the Kubernetes cluster itself. Now, the reason we set all this up, the infrastructure to start, of course, is because we want to get to the application map. And remember I said we want to make things a little bit more understandable. So from this perspective, this is the idea of making things a little bit more understandable. We put it in that familiar service map, and then so you can look at how different services are reacting. Now here's your end user out here. You get the end user response times, and so you can start to see how the end users themselves are actually impacted or what's going on there. And then if I dig in on any specific service, I actually can open a dashboard on a specific service, and I can start to see what the performance is over time. But more importantly, you can see there are some spikes here that go on. So I can actually dig in and look at traces themselves. And this is where you start to get into that idea of end-to-end and being able to drill into something specific. Now, none of these are particularly long. Like I said, we don't have any big problems out there. Let's go back to the map and let's see if we can pick a different service. Maybe down here. I'm looking for a shop service. So we'll go back to the product search. The interesting thing with the traces is that the nice thing is that they tie into the specific data that's there. So for example, here we have an Elasticsearch call, and you can get a little bit more detail about the Elasticsearch call and what it did. So we actually have the span for every trace and every search of this. These are product searches, so of course you're getting Elasticsearch calls that come here. But you see the span of where each step was spent. And so in a longer, broader, bigger service, you actually would have some code pieces. You could drill into the code. You might have some JDBC queries. You could drill into selects and the queries there. So that's how you go from the front end user back right to the system and then down into the specific traces themselves to solve problems.
Okay, very good, Chris. Two last very quick questions, and maybe you'll follow up with these offline, but one of those is whether or not there's any trial licenses for folks to play around with Instana, and the other one is whether or not there's detailed demos of the product online.
So the answer to those questions is yes and kind of. We do offer trial licenses. When you just feel free to come to instana.com and sign up for a trial. When we communicate with you after this event, you can just respond to the email and say you would like a trial, and we'll get you guys anyone connected and set up. And the nice thing is that things happen. It's really easy. It's surprise, surprise. It's automated. We care about automation. That's why we talk about it. As far as detailed demos of the product online, there are some interesting videos that are out there. Some of the older ones showcase some of the things we talked about today. We just released a nice little 4-minute or 2.5-minute video that showcases our new Kubernetes monitoring, and it actually shows all the things that you care about that we talked about today: discovery and drill down and automatic monitoring, but specifically to the environment of how it also includes Kubernetes monitoring as part of that. So that's on our YouTube channel. You can go out and look at that. But we're deploying more videos all the time these days. So be on the lookout for that.
Okay, very good. With that, I think that's all of the time that we have for questions today. Thank you for joining us to learn about Instana and the world of monitoring microservices. Just a reminder, the webinar recording and slides will be online later today. We'll be looking forward to seeing all of you at a future CNCF webinar. Have a great day. Thank you, Chris.
Thanks, Lee, and thanks again for allowing us to present to the organization.
It's great having you. Thank you all.